second video in AP Calculus for section 3.8, which is on derivatives of inverse functions. In the first video, we looked specifically at inverse trig functions, but in this video, we're going to look at derivatives of all types of inverse functions and try to see if there's any type of connection or relationship. So to begin that with, we're just going to look at one basic function. The graph of f of x equals x cubed here is on our screen. The first thing is if I wanted to find f of 2. Well, f of 2, which is means I go to where x is 2, and I look at the y-coordinate here. You'll notice on the graph that that would be a value of 8. Now, if I wanted f prime of 2, that would require finding the derivative of f of x, which would be 3x squared, and then evaluating it for x is 2. So we would end up with a value of 12. And from what we know about derivatives, what that means is that if I was to then sketch a tangent line at 2 through my curve, then that red tangent line there that I just drew would have a slope of positive 12. That also means that the function has a slope of positive 12 at the point 2, 8. Now, C wants us to think about the derivative, or the inverse, of f of x. Let's first think about what that would look like. So think about what you remember about inverse functions. Way back when you very first learned about inverse functions back in middle school, hopefully you learned that the basic concept of an inverse is that you swap the y and the x. So that literally means all of your points flip-flop. So for example, the point 2, 8 from x cubed would become the point 8, 2. I can also think through some other points that are on x cubed. For example, the point 1, 1, well, it would stay 1, 1. The point 0, 0 would stay 0, 0. Negative 1 would stay negative 1, negative 1. And then we would also have a point down here at negative 2, negative 8, but it would become negative 8, negative 2. So if we kind of connect these points together, this is the graph of the inverse function to f of x equals x cubed. Notice the inverse notation is to put that little negative 1 next to the f there. So the point 2, 8 would map to the point 8, 2, as we've already established. Now the next question that we are then asked is, what does f inverse prime of 8 equal? So what that is asking is, at this point of 8, 2, what would the slope of that tangent line be? Now, I can promise you that it is not 12 like we got in part B, because 12 would be a very steep slope. What I see there for that black tangent line that I just drew is a very, very flat slope. So, let's kind of think this through here. Think about, first off, what is the equation for that function that I just graphed, that lime green graph? Well, if we think back to what we were saying about swapping the y and the x's, to find the inverse function, we would take y equals x cubed, which is our original, swap the x and the y, and then if I was going to solve that for y, that would mean I would have to cube root both sides. So the inverse function is the cube root of x, or x to the 1/3 power, which means that the derivative using the power rule with that would be 1/3 x to the negative 2/3, or 1/3x to the 2/3. So I can then apply that to the specific x value of 8, and I would do f inverse prime of 8 is equal to 1/3 times 8 to the 2/3. Now let's talk about how to do 8 to the 2/3 without a calculator. The top number is the power in the fraction, and the bottom number, the denominator there, is your root. So this is saying we're taking the third root, or the cube root of 8, which is 2, and then the top number tells me what power to raise that to. So the cube root of 8 is 2, and then I'm going to raise that to the second power. So 2 to the second power is 4. So I end up with a value of 112. So if I go back and look at that black tangent line that I drew here, this black line has a slope of 112. That means that for every unit that it rises by 1, it runs over by 12, which is why it would be extremely flat like that and almost horizontal, because 112 is such a small number and then a small slope. Now, how does that number, the 112, relate to the slope that we got for the inverse point of 2,8 back there on the original function? Back here in part B, I had a slope of 12. But when I went to the inverse point, it had a slope of 112. Hopefully you can very easily see that connection there. The connection is that the derivative at the inverse point is going to be just simply the reciprocal of the derivative at the original point. So I'm actually going to take a minute here and kind of explain how that works to you. So given some function f of x, we're going to call g of x the inverse of f. So f to the negative 1 of x. Given that f and g are inverses of each other, we then know, this goes back to what you know about inverse functions, compositions of inverse functions always come out to equal x. Let me change my color so it stands out a little bit. So whether you do f of g or g of f, the answer always comes out to be x. Now, so if I take the derivative of that statement there, if I take the derivative of both sides of f of g of x equals x, well, on the left-hand side, that would require doing the chain rule. So we would take the derivative of the outside, so f would become f prime, with the inside left alone, times the derivative of the inside, which would be g prime of x. And then that's going to equal, I also have to take the derivative of the right-hand side. The derivative of x is 1. Okay. Now what I'm looking for is a formula for the derivative of f inverse. Well, remember, f inverse is the same as g. So I'm essentially trying to find a formula for g prime of x. So that means I need to isolate it by itself. Right now it's being multiplied by this expression right here. So to get g prime of x by itself, I will divide that by itself. Now remember, g is the same thing as saying f inverse. So f inverse prime of x is equal to 1 over, there we go, 1 over f prime of f inverse of x. Now, that may be a lot to take in with a whole lot of f's, and a whole lot of g's, and negative 1s, and primes, and what's what. But I basically just want you to remember that if it's inverse points, the derivatives are going to be reciprocals of each other. And I'm actually going to show you a chart that I find really helpful for kind of keeping this stuff straight. So, for example, looking back at example 3, I would have made myself a table to kind of organize the information. I would have started off with the point 2,8, and I figured out that its slope or derivative value was 12. Well, if 2,8 was the point on the original, then automatically 8,2 would become the point on the inverse. And as long as I can find the value of the original derivative, all I have to do to get to this final answer is take the reciprocal of it. So I'm going to show you an example of how that table could be really helpful here in example 4. So example 4 says if k equals f inverse of x and f of x is equal to x plus sine of x, find k prime of 3.5. So back in example 3, the way that we originally were able to come up with the 112 was by actually coming up with the equation for the inverse function and taking its derivative. Now if I was to try to do that here on example 4, by swapping the x's and the y's, I would have x equals y plus sine y. How simple is that going to be to solve it and get it back into y equals 1? Not very simple at all. So we can't really do that. So that's why the chart is helpful to me. So if I keep up in my chart, so I have x, y, y prime, f, f inverse. And in this particular problem, we're also calling f inverse k. So they are wanting me to find k prime of 3.5. So this is the x value for the k function. So that would be right there in my table. Now what I know about inverses is that it would then also be the y-coordinate of my original function, my x plus sine of x. Now if I can figure out the x-coordinate that goes with it, then I can find the derivative and then I can take the reciprocal of it. So I need to figure out when does x plus sine of x equal 3.5. So to do that, I'm going to go straight to my graphing calculator. And first you want to check in your mode and make sure that you are in radian mode. And I want you to type x plus sine of x into your y1, and then 3.5 into your y2. Then simply hit 0.6. We just want to graph these two things. So you get this nice little curve for x plus sine of x. And then 3.5, you're going to get a horizontal line through 3.5. Those two things are equal where they intersect each other. So press the second, calculate, and we want option number 5 for intersect. Then all you have to do is hit enter 3 times. And it tells you exactly where the intersection is. It's going to intersect when x is 4.471. So that means that this number right here is 4.471. Now, as long as I know what that is, I can then substitute that into the derivative of my original f of x function to find this box right here. So I need to find the derivative of x plus sine x. The derivative of x is 1. The derivative of sine x is cosine x. So now I just need to evaluate that for 4.471. So on your calculator, you just simply type in 1 plus cosine 4.471. And for this particular one, it would need to be a calculator problem because you couldn't solve it without it. And you're going to get 0.761. Once you fill in that box, it will take you about 5 seconds to then fill in the bottom box, which is that bottom box is the answer we're looking for. So k prime of 3.5, which is that bottom box, is going to be the reciprocal of the box. Oops, why did I put a 4 there? Right above it. So you would do 1 divided by 0.761, and you get 1.314 as your derivative value. Now I notice I have an empty box there in my table. That would also be the 4.471, but it was honestly irrelevant to the problem that I was trying to do there. Okay? All right. So I want you to now take a minute and work out example 5 on your own, trying to use the chart method. Okay, so I tried to color code my work here. I started off by making my chart there in red. The information I knew was that I was finding g prime of 2. So 2 would be the x-coordinate for g, which was the same as f inverse. Knowing that gave me the y-coordinate for f of x. So I then, over here to the left, set my f of x function, x minus 1 over 2x plus 1 equal to 2. Did the algebra to solve for that, and that gave me the x value of -1, which I then put in the f row. I then did the quotient rule here in blue, found my formula for the derivative, substituted -1 in, and got 3. That was the derivative of f. So then all I simply had to do was take the reciprocal of that, and my final answer there